Good afternoon and welcome in the Everlasting presentation. My name is Carlo Mol and I work at VITO in Belgium. VITO is a research institute working on sustainable energy technologies, and as project manager I'm responsible for our research projects related to electric mobility, smart charging and batteries. And in fact batteries is the topic of the presentation of today. As project coordinator of the Everlasting project, it's my pleasure to present you in the next 10 minutes some highlights of the research work we have done. As you can see, Everlasting project is still ongoing. It was foreseen as a 4-year project, but due to impact of COVID on the planning of our demonstrator, we got a 6-month extension, and now the project is running until February 2021. It's a project that exists out of 11 partners coming out of 6 different countries. And as you can see, it's a nice mixture of universities, of research institutes, and of course also industry. And we have quite some innovative SMEs on board too. Everlasting objectives, as you could see in the title, it's all about batteries, improving the performance of the battery, improving the lifetime of the battery, and at the same time try to reduce the cost. Of course, getting more energy, more power out of a battery, you always have to make sure that you stay within the safety limitations. So also safety is a very important aspect. To manage a battery, you definitely need a well-performing battery management system. So we did a lot of research on these features, and at the same time we looked at standardization possibilities. Are there parts in the hardware, software or interfaces of the BMS system that could be standardized? It's an open question. Everlasting was built up on about 9 work packages. I only have 10 minutes a day, so I want to focus on a few of them a bit more in detail. In fact, I made a Zoom recording which is longer and contains all the work packages. It can be found on our Everlasting website and LinkedIn group after the conference. For today, I focus on the demonstrator and some other work packages. First of all, the demonstrators that we have used or built. We have the Voltia eVan that you can see on the left side. And we also have the full electric bus of VDL that we have used for the driving range estimation and extension research tasks. The Voltia eVan has been used more to build a battery pack from scratch and to test some real new BMS innovations in it. In this slide, you can see it a bit more in detail. So Voltia is a company from Slovakia. They build electric vans for logistic purposes. They work closely with Nissan for that, but in the past they also used Citroën Jumper as a platform and retrofitted vehicles to an electric van. For that, they built in quite big battery packs. They used the battery swapping system at that point, which makes it very interesting for a research project, because then it's easy to integrate a new battery in the existing vehicle. So what did we do? We built a battery pack from scratch. We built also a BMS system, a new BMS system from scratch. I will tell more in work package 6 later on that. And on top of this BMS system, we implemented some of the BMS innovations we developed. Some innovations were related to state of health evaluation, and others were more related to the prediction of thermal runaway precursors. How can you see that something will go wrong in a battery? We installed some extra strain sensors in some cells, or we developed some diagnostic algorithms. But more questions can be asked in the Q&A for that one. All the other research things we did stayed more in the lab and simulation scale in the other work packages. The second demonstrator was a full electric bus from VDL. In fact, VDL is one of the main players in Europe on electric buses. They have a lot of experiences in designing and manufacturing such buses. And in this project, they went one step further in the sense that we used an existing bus with a certain powertrain in it. We modeled the whole powertrain. We modeled all the components, not only the battery, but also the auxiliaries, heating, ventilation, all these things, cooling. And we used a virtual simulation tool coming from Siemens called AMSIM. And thanks to this tool and the intensive modeling and measurements we did, we were able to improve the driving range estimation, and we also improved the extension. We improved the driving range itself. We got more energy out of the existing battery than before, thanks to a very efficient prediction of the power consumptions and a good energy management system in it. Looking at the time, I have to continue, so let's move over to the next work packages, work package 2, 6, and 8, and now we start with work package 2. Just to say that if you want to develop state of health algorithms or make an estimate of the battery life, 2 parameters to have the right background information, you need sometimes a lot of test data. As I said, we have a cylindrical cell chosen for our battery pack, and we did a lot of tests on this cell, a lot of characterization tests. We also did a lot of destructive testing, nail penetration, other things, and very much aging testing, calendar aging, putting the cells under different climate conditions at the same time with certain test cycles. So we collected a huge amount of data on this. The nice thing, and that's what I explicitly want to mention here, is that Everlasting participates in the open research data pilot, which means that some of the data sets, which are not that confidential, so especially the aging testing we will share, we will give access to others who are interested in this data. So the data sets will be put in a repository at one of our partners, TU Eindhoven. So at the end of the project, end of February, please have a look at this repository and check for the open data sets of Everlasting. The whole reasoning behind this is, of course, that European Commission puts funding and money in the projects. We do a lot of testing, and it would be good that some of this knowledge and data can be reused by other research institutes or companies. Going to the BMS testing, very quick because I have to look at the time. As I said, the suit was looking at how do you test a BMS system. Up to now, most of the time a BMS system is integrated in the battery pack, and there are a lot of tests that need to be done before a battery pack goes into a vehicle. But of course, we also want to test a BMS as a separate entity, not always in the battery pack itself. How do you do that? How do you evaluate the performance of a BMS system? It's not that easy, and TÜV SÜD put some effort in this to investigate that. As I said, a BMS system can have a lot of different features. We know that it's impossible to test all features in a BMS test. So we made a kind of pyramid with things that you really need to test and then some nice to haves maybe in the future. We developed a lot of public deliverables on this. Do read these things if you're involved in BMS development. It's very interesting to read this thing. They are available at our website. This brings me to work package 6, which is about the BMS standardization. And of course, work package 6 was also related to the design and the manufacturing of the BMS that has been installed in the Voltia EVAN. So part of the work is for the demonstrator, and part of the work is to share information to the industry, to the other stakeholders outside of Everlasting on BMS architecture standardization. Maybe I use the following slide for this. This gives you some views on the BMS system that has been developed specifically for the demonstrator vehicle, the Voltia EVAN. We developed one master board and 14 slave boards. As you can see here in the battery pack, these are all the slave boards. These things have been developed by LionSmart, the partner in our project. So they designed the hardware, the software, and the interfaces to the vehicle and to the cloud. before installing it into the battery pack, they did a lot of hardware in the loop testing in their own test bench, and our partner TÜV Süd is doing all the other tests on the battery pack itself. So that's about the BMS for the demonstrator. The other thing is we build up a lot of knowledge on battery management systems, and it would be interesting to standardize certain parts. Maybe there are some parts in the hardware, some in the software or in the interfaces. Of course, Everlasting didn't have the ambition to write standards ourselves. The information we have is input for a pre-normative technical standard for BMS architectures and functionalities. This is really an interesting topic. We collected a lot of info, but we also noticed that standardization takes time. It's not that easy to implement a standard, and especially a BMS system in a battery pack, it's a bit of the core expertise and a differentiator of your battery pack. So it's not that easy to share too much detail or to standardize too much. So there has to be still a difference between the market players on this one. Nevertheless, we did a lot of study work on BMS. We did a bench state-of-the-art study, which you can find on the website, and we did some proposals on an open standard on hardware, software, and interfaces. And to get input from the stakeholders, we did also a standardization workshop in May 2019 in Germany, and we did a workshop, collected feedback from the stakeholders, and also visited our partners TÜV Süd and LionSmart. I think my time is finished. Last thing maybe to remind you on is that dissemination is also important in Horizon 2020 projects. Everlasting has really a lot of scientific publications, so I like to thank my especially university partners on really publishing this much interesting material. On the other hand, it's not all scientific publications. What we also try to do is to raise awareness to a less technical audience, and to show that BMS systems are important, that they play a vital and positive role in batteries. And we wrote every 3 months a kind of white paper on a different topic on BMS, explaining the different functions, what is state of charge, what is state of health, what is cell balancing, what is thermal management. All these things are explained in our white papers and are available online. That's all from my side. These are the contact details from myself and also the dissemination partner, TU Eindhoven, in the project. We have our own website, but also these 2 days in this conference, we have an online exhibition where you can get in contact with us to ask much more detailed questions. That's all from my side. Thank you for your attention and looking forward to the questions in the Q&A.